So from here now we have something that looks like it could be a hex bolt if you were to take it and extrude it. So we're going to finish the sketch, and then we're going to use our extrude tool again. Now here, because we have a couple different polygons in here that could possibly extrude it, it doesn't automatically select. For example, you could click on that inner circle, and it would try to make a cylinder from that inner circle. Or you could click on the hexagon, and it'll make the hexagon minus the inner circle. Or if you click on both, it'll make both. So you can tell which it's trying to extrude because when you mouse over it, it'll highlight it partially red. So you're going to want to click on that middle part there with the hexagon. And then we're going to extrude it 1/4 inch because that's, or let's extrude it 0.2 because that's fairly regular for a bolt. And from there you have a hex bolt. All right, you have your extrusion. All right, now something that you can do to practice is let's try to create a bolt that will work for this extrusion. What the bolt will entail is it'll have the actual bolt length, which will just be a cylinder, and that can be 1 inch long. That can be however long you want it to be, and then it'll have a bolt, head, which for our purposes can just be a circle with a hexagon in the middle to put your wrench. So let's do that. Create a new part and try it out. If you guys now you have two parts that you've made. You have your nut and you have your bolt. So in real life you need to put them together, but you don't want to do that with by putting them together in the same part because then they'd stay together, and you want to have each part be a separate physical object that you'd have in a real object that you build. So what comes in here is something called the assembly. And what the assembly is it takes two separate parts and you can add a number of constraints so that they basically merge with each other. So from the same drop-down menu that you created your part from, you're going to select assembly, and once it feels like it, it'll make a new assembly. So from here, you have a blank assembly. It looks like a part, but the difference is instead of creating sketches to make the part, you're going to place two or more parts and join them together. So you click on the place tool, and you go to wherever you saved your parts. I just saved mine to the desktop. And then you click on one, and it allows you to place it. You can place multiple. I could place like 4 if I was adding 4 bolts to a piece, or you can place just one and cancel out of it. So now I have my nut, or my bolt, and now I'm going to go in and I'm going to place the nut. And as of right now, you can drag them around freely. They're not joined to each other, so we need to fix that. Now, the first constraint you're going to use is actually a circular constraint. It'll be able to tell what you're trying to do. So from here, you can just zoom in on the cylinder inside of your nut and click anywhere in the cylinder, not on the circle around the perimeter of the cylinder, but the actual cylinder, and you'll see a dashed line representing the center of that circle. And that dashed line is going to join to another dashed line of a secondary circle that you create. So if you click on this dashed line, zoom out, zoom in on your nut, and then you see the second dashed line forms. Now the dashed lines are collinear. Oh, I didn't.
They make things unuseful.
So now you can still drag it up and down on the bolt, but it stays true to that dashed line. So from here, the second most what's probably the most common constraint you'll see is simply merging two faces together. So constraint, if you click on one face, you'll see a vector showing the direction that the constraint is being placed in. And you know that's the direction that the second face is going to be attaching it from. So you click on once on that face, rotate your model, click on the second face, and now it'll join those two faces together. So you can still rotate the bolt on here, but it's now joined to that central part of the bolt, and it's joined to the face at the end of the bolt. When you get into full CADs, like for example the CAD of the robot this year, you'll have a number of layers of assemblies. For example, for the shooting mechanism this year, there is an assembly for the spring that went into an assembly for the shooter, that went into an assembly for the pickup, that went into an assembly for the full robot. So you'll see that really keeping an organized hierarchy helps keep everything in line, and you can zoom into individual parts and try to focus on editing just those parts. For example, over here, this is a render of, oh, where'd it go? Whatever. I used to have a picture of the render of just the shooter module, and you could isolate that because I had that shooter module as a separate assembly. And within assemblies, you can actually place other assemblies, and they'll act as a part. And, oh, right. Also, something I should probably talk about is this menu up here is probably one of the most useful things that you can have, because it shows you how everything is organized in an assembly. Right now you see you have the two parts, the nut and the bolt. So from here I can open up the menu and I can see the individual parts. I can see their origins, that sort of thing, and I can also see the places where they're constrained. You can also get to that menu in the sketch, and that'll give you more detail in terms of like what your extrusions are and what sketches those extrusions are based on. Another really fun part with constraints is if you decide to go back and change a part and you have to redo an extrusion because you've edited the sketch too much, what I've tried to do a couple times in CADing the robot this year is that it will actually delete any constraints that you have. So you'll be moving the arm, and then all of a sudden, all the nuts and bolts that were attached to that arm will just be gone. So to prevent that, keeping things in multiple assemblies is very helpful. So this is a CAD for the robot this year, and as you can see, there are a number of assemblies. And in here, let's say go into pickup, it opens up. There are assemblies here. There are more assemblies here.
Did you put all the holes in?
All the holes in?
Yeah.
Yeah. Why wouldn't I? I mean, we had to manufacture them. Also, when you get to
There weren't in earlier.
when you get into parts like this, it's really important that everything's how it should be. For example, for this part, this is a part that we gave to Mad Labs to have them cut it. So from here, I needed to make sure that all of the dimensions fit in the CAD perfectly before having this part manufactured, so that when I exported this model and gave it to Mad Labs, they took their plasma cutter and they cut this actual physical piece out of sheet metal that it would fit in the CAD with everything. And other than the chain, it did.
Quick shout out to Mad Labs.
Yeah. Yeah. Yep. All right. Well, thanks for coming. I have to get going.